Gross. That's just paper, you goob. All right.
Dude, you waste nothing in that sucker. Zero waste of resources.
In this economy, everything's with a purpose.
Everything with a purpose. Lovely. Okay, so we're still talking about finding limits algebraically. So yesterday we talked about a couple of things. So first of all, just to remind you, what's the first step in solving any limit? Plug the number in for x, okay? Because I promise you, you're going to assume that if it's a fraction, that it will be 0 over 0, and I will almost 100% guarantee you that I will give you one at some point that's not. And so you'll be trying to factor, and you'll be frustrated because it doesn't factor, or you'll be like, what the heck? This doesn't even work. It's because it's not 0 over 0. So just don't assume that. And we talked about then, if you get 0 over 0, what's that called? It's called indeterminate. And go ahead, Andy. It indicates that what's in the graph. It indicates that there's a hole in the graph. Indeterminate. Okay. Indicates that there's a hole in the graph. And so we talked about yesterday, one of the ways to remove the hole is to factor. Okay. When you factor it, it reveals where that hole is. So I told you there are three things. Indeterminate tells you do something else. Okay, and so I told you we're going to talk about the three something else's. So the first one was factor. So we're talking about the other two today. All of them. They're all going to be 0 over 0. That's the only indeterminate form we talk about right now. And they will always come out to be 0 over 0. And so we just have to come up with other ways to deal with them. So let's see. The next kind of indeterminate that we could find would be something like this. So notice, first of all, it doesn't look like the ones that we did yesterday. So the nice thing about the three ways I'm going to teach you, like you don't have to guess and be like, whoa, if this one doesn't work, I'll have to try the other one. Like it's one. There's one way that will work for it based on what the thing looks like. Okay. So first of all, is it 0 over 0? It is. It's a little bit easier to tell on this one. You don't have to do quite as much work. So 0 over 0. So if it looks like this, then what you have to do is expand and simplify. So you got to expand the top in this case and simplify. Pinched it. It has been like that for a while, and it unfortunately didn't go away, and it's growing out with my fingernail. I think when I was pumping gas. I don't even know. It was like a month ago. Don't remember. I just remember that it hurt.
You didn't spill any of that gas, though, right?
What'd you say?
You didn't spill any of the gas.
I did not. I know, right? Okay, so just like yesterday, we talked about the fact that we're going to do the work and it's frozen. We talked about the fact. We'll try this again. I had some coffee this morning, and I can't talk right. Yesterday, we talked about the fact that we do this work over to the side so that we have less writing to do in the actual line of the problem. Because every time, if you're going to put it in line here, every time you change what it looks like, you would have to rewrite the limit thing. You don't want to do that. Okay, so just trust me. And we'll do it over to the side. So when we expand the top, just remember, I'm not going to do this every time. You can do this in your head because you're smart enough. But remember that that's x plus 3 squared. Okay, is x plus 3 times x plus 3. Okay, so let's talk about, I talked to you yesterday about factoring hacks. Listen to this hack. You got to know this already. Some of you know this. But I'm going to multiply. I'm going to get x squared. And I'm going to have a 3x and a 3x, which is going to be 6x, right? Like it's just going to be doubled what's here. That's always true because of the way this is. It's something squared. It's going to be 6x plus 9 minus 25. And then we're going to simplify that one more. This is x squared plus 6x minus 16 over x minus 2. Now, here's what I'm going to tell you. Like, this is, like, you're going to be like, this is a lot of math. It's actually very beautiful math, because if you put a 2 in here, what happens on the top?
Something.
Thanks. Put a 2 in for x.
Oh, put a 2 in for x?
Put a 2 in for x. It's 0 over 0. Okay? No, 0 over 0 means you still have to do something else. So you factor this. And this is nice because you know what's on the bottom. So if there's an x minus 2 on the bottom, you know there's an x minus 2 on the top because it's 0 over 0. And so what's your other one? Yeah, x plus 8. And so then you bring that, once it's all simplified and you found the whole, because the whole idea is to remove the whole. So you have to factor it to remove the whole. Then you go, okay, we're going to redo this, but it's actually going to be the limit as x approaches 2 of x plus 8, which is 10. So the only difference is, first of all, what it looks like. You're still doing algebra, so it's going to be expand, and then probably you're going to have to factor again. Okay, because it's and so every time it comes back to factoring, because factoring is what reveals where the 0 is, or reveals the zeros and shows you what's left. Okay, so try this one, please and thank you.
Too much. There's a way to do this on our calculator.
There isn't.
Can figure it out. It's gotta be.
There isn't. You have to get into the ones with a computer algebra system in them. They say CAS on them, and then you might be able to do limits. I'm not 100% sure. I have a big calculator, and that will do limits. The one that looks like it's a,
Little tablet one.
yep. Okay, what's the answer? Final answer? 4, correct. So this is, when you expand this, x squared plus 10x plus 25 minus 4. Minus 4. So x squared plus 10x plus 21, which factors to x plus 3, x plus 7 over the x plus 3. And so what you're left with is the x plus 7. So make sure you write it. Say it 4,000 times. You're going to get tired of hearing it, and somebody will still not write it. X plus 7 equals 4. Okay? Okay with this? Do you need to do another one, or are we okay?
I'm good.
Okay, because I would rather spend more time on the last one. Nope, we're going to do one more. I lied. Sorry. This one needs it. Let's go limit as x approaches 5 of x minus 2 squared minus 9 over 2x minus 10. Okay, this is worth doing, and this is why we're doing it. So give it a shot and see what Really?
It was not me, it was Weston.
So here's where you get a little bit into the weeds. Okay, the top does factor, and you know there has to be what factor to create the whole? Minus 5, right? X minus 5, because opposite. What's the other one? X plus 1, right? X plus 1. Now, problem is, here's where we would have this on the homework, and then you'd be like, you didn't tell me this. Okay, this, what you got to do? Yeah, you have to undistribute the 2 because that's where you're going to come up with the X minus 5 if you undistribute the 2. So sometimes you have to factor out a constant number like that, and that's okay. Okay, so we got the limit as X approaches 5 of X plus 1 over 2. Yep. So then it's not like the math is any harder. It's just, it's nice for somebody who's instructing you to tell you that sometimes you have to pull a 2 out or pull a number out. So just watch for that. Okay, so number 1 was factor. Number 2 was expand, simplify, and factor. And the last one, which I'm just going to put down here, we have to rationalize.
Oh.
I don't either, but I also remember having the same reaction to it. So.
Okay, so
Oh, that's false.
now I want
Yeah.
you to okay. I don't want that.
Interesting.
Yo, let's just not do it.
No, you have to do it, but I don't want that problem. Not yet.
Not yet.
You should invest in erasable pens.
Yeah.
I don't like them. I don't know. I could invest in erasable pens, I suppose.
I should invest
Okay, let's go
I didn't know
X
you could erase them.
plus 7. Okay, this is what I want. Okay, here we go.
So if you have an erasable pen written on paper and then you put the paper on a heater, all of your
It all
erasable
goes away.
pens disappear. I did that once for a competition.
Oh, yikes.
All my statements of authenticity that I all signed and stuff, they were sitting on the heater in the car, and then they weren't signed anymore, and we were all like, what happened? We were so confused.
Yeah. Okay, so this guy, first of all, if you plug him in, is he 0 over 0? Now, I'm gonna, don't write this down, but I want you to imagine back to a couple, like chapter 3. I know it was a long time ago, you probably don't remember. Let's say we had this. Like we were rationalizing things like this.
You gotta put the square root of 2 on the top.
Well, the other things that we would rationalize is maybe things like this, right? And that's where, what's this by when you rationalize them? 5 square root of 2 over 2. Because what we're doing is multiplying by the square root of 2 on the top and the bottom. Okay? When there is another piece in there, though, added or subtracted, we have to multiply the top and the bottom by, nope, what is that? The conjugate. To multiply the top and the bottom by the conjugate of the bottom. Now, that's called rationalizing the denominator. Okay? Look at this. There is no square root on the top. There is no square root on the bottom. He's on the top. Okay? All right, leave me alone. It's the coffee.
I don't like that.
There's no square root on the bottom. The square root is on the top. And so what we do is rationalize, and just the act of switching the root to the bottom makes it so that you can do it. It's weird. And if the square root was on the bottom, if you rationalized it, moved it to the top, it makes it so that you can cancel things. So there are some nice shortcuts that we can do in here, okay? So what we're going to do is we're going to multiply by the conjugate, in this case, of the top, because it's the root thing that you always want to get rid of. So we're multiplied by the square root of x plus 7 plus 3. Okay, now here's the good news. Okay, this is not going to be as bad as it looks. It looks bad. It's not going to be as bad as it looks. Okay, when you multiply the conjugate, this is a conjugate rule only, but when you multiply the conjugate, you only have to multiply the first one and the last one because those other pieces will cancel out. Always will cancel out. That's the power of the conjugate. Okay, so what is the square root of x plus 7 times the square root of x plus 7? It's just x plus 7. So this is x plus 7, and this is -9. Now, the top is x minus 2. Now, here's the other good thing about this. This looks like it's brutal multiplication. Never, never expand to the bottom. Okay? Or the top, as the case may be. Because square root x plus 7 plus 3, look what happens. I didn't expand it, and look what I have. I have matching factors that I can cancel.
Where'd the one on the top come from?
Okay, so when I multiplied, I got x plus 7, right?
Oh,
Guys,
that's
Minus 9. 7 minus 9 is -2. So I just simplified this. Now, this goes back to what we were talking about earlier today when we went over our homework. This is some stuff. Where is it? It's on the bottom. Okay, don't let it float up or you're gonna get it. Yep.
You'll get there.
Yep. You're gonna get it wrong. There we go. So it's that. It's on the bottom. Make sure it stays on the bottom. Put the 1 there. And then you plug it in and evaluate.
1/6.
1/6.
Booyah.
How do you know that? Square root of 9.
Because plug in a 2?
6.
Yeah. So these look like they're terrible because of the square roots, but the shortcuts in the math make them a little bit nicer. Okay, so we're going to try a couple of these. So let's try the limit as x approaches 4 of 2x minus 8 over square root x plus 12 minus 4. Okay, first thing that you want to check is it 0 over 0? It is. And it's always good to check, even when we're taking notes on this, because sometimes I do my math wrong and then it's wrong. It's not what I wanted it to be. So in this case, we are whoops, I didn't want to do that one. What are we going to multiply by?
Something.
square root x plus 12 plus 4.
Yes. So square root of x plus 12 plus 4. So this time the root is on the bottom. We're going to rationalize him so he's on the top. So wherever it is, wherever the root is, that's the thing that you do the conjugate of. It just switches him to the other side, and just the rewriting of it makes stuff work out nice. So x plus 12 plus 4. Okay, so this is now do not multiply out the other one that didn't have the root, x plus 12 plus 4. Okay, the bottom, just a reminder, this is, only do the first piece, so x plus 12 square root times x plus 12 square root is what? This is x plus 12. So, and then we do the other one, which is what? Okay, so then I have this, I'm crossing this out, that's x minus 4. Okay, now, this is, again, is this situation where you go, I don't have an x minus 4. You do.
Take the 2 out.
Take the 2 out of here. So this is 2x minus 4, and then all this stuff. I'm just really being lazy about this. I'm sorry. So it's 2x minus 4 square root x plus 12 plus 4 over x minus 4. Okay, that's what that all boils down to. Cancel that. And then you've got the limit as x approaches 4 of 2, square root x plus 12, and then plus 4. Mm-hmm. Okay, last one.
Will we ever have to do stuff with like eyes and stuff?
No, nope. Calculus does not involve unreal numbers at all. Not at the level that we're doing it.
And I can learn it.
Nice, you said that I can learn it.
No, why did I learn it?
Imaginary numbers, because there are some branches of math that use it. You go beyond calculus 1, you get into imaginaries. Probably not more than, yeah, 2 fine. You probably can erase imaginary numbers from your general vocabulary. We had that discussion. So we're talking about domain and range in algebra. And so, you say the domain is all real numbers. And I'm like, any number you can think of is a real number. And then like, what is a not real number? And I was like, oh, would you really want to know? Yeah. So I told them. And they were like, what?
They didn't like it.
No, they didn't like it. I was like, I told you you didn't want to know.
Who would want to know? Be real.
Okay. What's the top simplified to? Well, I got 3x plus 10 minus 4. So 6, yep. It's just 3x plus 6 over this stuff that's on the bottom. Now it looks like nothing cancels. Undistribute your 3 on the top, leaving it with x plus 2, which you guys go back to here. If you're like, I don't even know, go back to this and realize there is still a hole in there because we haven't taken it out, and the hole is at x plus 2. So it's got to have an x plus 2. And you take the 5 out. So then you have the limit as x approaches negative 2. 3 over 5, and then the mess that we have. 3x plus 10 plus 2. Because the parentheses are really important for getting the right answer here. Like that 5 is multiplied by this whole thing. So don't be lazy about the parentheses, because otherwise if you don't have it, you're going to end up with 15x plus 10 plus 2, and that's wrong. What's the answer?
3 over 20.
I think so. 3 over 20. What?
I swear I got 1 over 5.
He's busy chewing on his stick.
I know.
What?
No.
Why?
How do you get? I'll come look at it because I can't even imagine how you got that.
But I got the same numbers as you.
I got 1 over 5.
Oh.
Tried it.
Yeah.
How did you get 12 over 5?
Because I did 5 times 3 and 5 times 4.
So I agree with 15 or something.
Yep. Okay, so those are, you guys, when you get 0 over 0, when you get 0 over 0, these are the only 3 things that we're going to talk about this year that you potentially could do. There's one more, but it involves a bunch of fraction math, and we'll talk about it next year. So, there you go. Let me stop my video a second, and then I'll give you your worksheet.